So the title of this presentation is Energy Intensive Industries, Energy Efficiency Policies and Evaluations. And I've been a frequent participant of these seminars or webinars by DSM University. So it's an honor now to be able to present my own results. And I will base this presentation on my doctoral thesis. That was research conducted in the years between 2008 and 2013. So Fernando already mentioned my personal background, professional background. So I don't need to talk about this here. But as mentioned, my presentation is based on my doctoral dissertation. And I provide you with a link here. So this is the content of my presentation. It involves 3 major areas and policies directed against the energy intensive industry in Sweden. First of all, Swedish program for energy efficiency in energy intensive industry, PFE. I will present some bottom-up evaluation results and also a top-down study. Secondly, industrial energy management. It was a core obligation in the program PFE. And so I will mention issues concerning the implementation and evaluation of. And thirdly, EU emissions trading system, of course, very important here. Considered by some the flagship policy for energy intensive industry. So I will start first with the background to this research. Energy efficiency is both cherished and disputed. We have, probably most of us have heard that EAA make this statement and observations that it is the least cost strategy for meeting long-term climate mitigation targets. And this raised the question, do societies need industrial energy efficiency policies? Well, there are different answers to these questions. And I'm sorry for using these stereotypes here. Economists on the left side and energy technologists on the other. But it simplifies my, it portrays my way to explain here the different standpoints. There are, of course, variation. Not all of them are like-minded. So to answer this question, economists argue that no, efficient energy use has no priority over other production factors. Market prices alone can guide rational decision making. And energy intensive industries in particular have high energy cost shares. And so they are constantly aware of energy related issues. On the other hand, energy technologies argue that energy resource efficiency is an important objective in itself. There are also climate environmental benefits and many other benefits. And recently we are talking about multiple benefits, which is very interesting for an evaluator to evaluate. And the energy technologists also argue that energy efficiency can free up capital for other purposes that are more meaningful or more productive than wasteful energy use. And then there is this difference between market failures and market barriers. While economists argue that only market failures can justify policy intervention, and the benefits must outweigh the cost of a policy intervention. And when choosing policy, they say that tax is the #1 policy to enhance the market signal. The engineers, they say that barriers of many kinds can inhibit decision-making that are energy efficient and profitable. And policies need to overcome these barriers to provide many benefits. And they can be creative and come up with a range of policies from regulative to informative that can address barriers. And of course, the way that you account for the industrial response to energy efficiency policy is different and between economists and engineers. While engineers, they look often at the direct cost of equipment and operation. Economists, they also consider aspects such as rebound effects, market interaction, and the heterogeneity of firms. And the result will be different cost curves for the energy efficiency potential, where engineers' cost curves can involve negative costs and may underestimate the true cost of energy efficiency. So there are many reasons for conducting this kind of research on industrial energy efficiency policies and markets. As we have seen, it is a disputed area which calls for evidence. Industry is an important contributor to wealth and employment. At the same time, it has large external effects, and the mitigation potential are very large. For example, the direct industrial greenhouse gas emissions account for 21% globally. In addition, there are indirect emissions from electricity use. There is also a complexity involved here. Energy and climate policies are becoming increasingly complex. And I state the example of EU ETS and the third period allocation procedures here. It is important to disseminate knowledge about intended policy theories, impacts, and outcomes. These issues should be scrutinized and understood outside their closest circle of bureaucrats. And regarding public and private goals, it is often so that energy policies have multiple objectives. But ideally, the private and public sphere can share common goals. This needs to be examined closely by evaluators. So, to improve policy, the success of the target-oriented EU policy regime requires knowledge and capacity building. So evaluation is key to this, for policy improvement and learning. So in my first paper, about the Swedish program for energy efficiency in energy-intensive industries, PFE. I wanted to evaluate the impact and the process involved in PFE. It is the major energy efficiency policy targeting energy-intensive industries in Sweden during the years 2005 to 2014. I used impact evaluation approach, which was based on a bottom-up methodology, partly developed by EMIS project. I encourage you to look at this reference. I also used the process evaluation approach, which was inspired by a theory-based evaluation. Policy theory here should be understood as the basis for how program activities are expected to bring about desired change. So the data I used was company reported data to the administrating agency, Swedish Energy Agency. Well, to describe PFE, it is a policy package. It involves incentives and obligations. The main economic incentive was the exemption from EU minimum tax on industrial electricity use. As an obligation, participating firms had to achieve electricity savings that were at least equal to the effect had the minimum tax been applied over the same period, a contrafactual scenario. So you can see in the image what the policy package includes. It's a 5-year program. During the 2 first years, companies need to conduct energy audit and analysis. They need to implement and certify energy management systems, first according to Swedish standard and later according to ISO 50001. They need to identify electricity saving actions and report them to the agency. And they have to implement procedures for energy efficient procurement and project planning, basically involving life cycle cost accounting. And in the 3rd to 5th year, they need to continuously improve their management system, implement the reported savings actions, apply the procedures, and estimate the results of procedures. And this program lasted between 2005-2009 in the first period and 2010 to 2014 in the second period. And then it had to terminate because this state aid was granted only for 10 years. This exemption from EU minimum tax. So this is how PFE is intended to work. And some results are that the PFE generated gross annual impact 5 terawatt-hours, which is considerable. It is almost 5% of the baseline electricity use of the 100 participating firms. And I use this gross to net conversion based on EMIS guidelines. And I could estimate net annual impact from about 700 gigawatt hours to 1 terawatt hour. This clearly exceeds the estimated impact of a contrafactual minimum tax. There were also multiplier effects, heat and fuel savings, almost 1 terawatt-hour. So these were cost-effective electricity savings. Average payback was 1.5 years, and the societal cost per saved kilowatt-hour or megawatt-hour, excuse me, was, as you can see in the slide, well below the price of new production of electricity. So PFE has been the impetus for organizational changes that can have long-lasting effects in terms of industrial energy efficiency improvement. It could be improved in terms of evaluation plan, but the reporting and documentation procedures were satisfactory. And I also did a paper here which involved the top-down analysis of energy performance in Swedish pulp and paper industry. So I did this to disentangle the influence from activity, structure, and energy efficiency improvement on the pulp and paper industry's energy use, and to explore development trends for different performance indicators. I used the decomposition method as stated here, and a very good data set, disaggregated and consistent, involving 27 product categories and specific energy use at product level. It has been systematically surveyed in the same way since the 70s. Those of you who are familiar with the composition studies will recognize these bar graphs, bar charts. On the left hand are period-wise decomposition. On the right hand, total results of the whole time series. So basically what you can see from this is that in black is actual change in energy use. Blue is the change from the activity, the production volume, change in energy use, I mean here, from changing production volume. And red is the structure or production mix. So changing from one product with a certain specific energy use to another will involve a change in the aggregated figures. And last but not least, the energy efficiency in green, where you can see that the energy efficiency at the product level has increased and improved in the recent period since year 2000. So, as I mentioned, energy efficiency improvement led to avoidance of 1.4 terawatt-hours electricity use in this period. There were also substantial savings in fuel use and primary energy use. And the electricity savings, they were negligible until year 2000, but sizable thereafter. So about 600 gigawatt-hours in the period 2000 to 2007, and equal in the period 2007 to 2011. So it clearly demonstrates that the case for industrial energy efficiency, but also CO2 emission reductions, was strengthened in this post-year 2000 period. And this corresponds well with the previous bottom-up evaluation results. The period-wise electricity savings of 600 gigawatt hours. They agree well with the pulp and papers industry's electricity savings in this PFE program, period 1 and 2. So it provides some evidence for accuracy of the reported savings and the success of PFE. So PFE involves energy management systems. It is a core requirement. And in 2 papers, I studied the implementation and evaluation of energy management systems. So these studies involved many questions, basic questions about how these management systems were structured and put into practice. Keep in mind that this was the first time that Swedish firms had certified management systems in energy, concerning energy. So we didn't know much at that time how to conduct certified energy management. So as a researcher, I wanted to find out. I also wanted to know if there were any measurable effects and other outcomes from energy management systems. And I think also the issue of management systems based on the idea managed by objectives that are firm internal. I believe that it can be questioned if these should be evaluated or not. So what are the objectives for energy management system implementation from private and public perspectives? And which indicators should be considered for monitoring and rating success? So I did semi-structured interviews with energy managers and coordinators during site visits at 8 different pulp and paper mills. I also interviewed staff at the Swedish Energy Agency, and I involved the certification companies through interviews and secondary sources. Here I wanted to show some pictures from the industry. So here are the spruce forests, the raw material for pulp production. Here you can see a pulp mill, chemical pulp mill, a large one, producing market pulp. Here they are replacing their debarking drum, a big piece of equipment. And of course, such a project will involve large energy efficiency potentials when changing motors and control and regulation of motor drives. Here is a picture of the boilers and how the pulp is dewatered and goes through the pulp machine and it's being dried out. And here is the back pressure turbine. This particular mill is more or less self-sufficient in energy and generates large amount of electricity. And there is the final product, the market pulp, which is then shipped, exported to standalone paper mills. So what I could find out was that there is no standard implementation of energy management systems. They are tailored to fit the firm's cost structure, the customer demands, physical infrastructure, and so on, not at least perception about the future. There is always the energy management system coordinator who is responsible for communicating, managing activities, sharing meetings. 2 to 6% of total staff are directly involved in energy management system activities. The advanced submetering is very beneficial in monitoring and verification. And these practices, monitoring and verification practices, have improved since the management systems were implemented. But a few mills, they lack sufficient infrastructure for submetering and cost allocation. The training of staff was in general not very prioritized. And concerning evaluation of energy management systems, I believe that if governments are to stimulate implementation, the public goals ought to be defined, communicated, and fulfilled. So it's a good case for evaluation. And the indicators of improved energy performance could be better defined by firms and public agencies, then monitored and ensured that continuous improvement has been the result. So energy management system targets can be conflicting. Some kind of prioritization can avoid suboptimal outcomes. And if economic incentives are provided, I think that certification should be required. And competent auditors have a role in the public agency's evaluation plan. So, documented activity of the energy management system team at the firms could reveal useful indicators for monitoring issues such as progress and ambition level. So now concerning EU ETS, the EU emission trading system. This research involved one article and one book chapter together with co-author here. The EU 2020 strategy expects EU ETS to be the key policy instrument in delivering cost-effective climate mitigation in energy-intensive industries. So I posed the question here, to what extent has ETS influenced climate strategies of major pulp and paper companies? Have they adopted offensive and innovative abatement strategies? So we conducted interviews with managers for CSR questions, corporate social responsibility, as well as energy and environmental affairs at 2 major pulp and paper companies. We also did quantitative analysis of EU ETS data. What we could see was both companies, they accept the challenge of climate change. They accept to participate in EU ETS. They are only critical on specific issues. For example, how it will influence electricity prices or the risk for carbon leakage. So they accept the challenge and they want to take responsibility. And already before EU ETS, they had CO2 emission reduction objectives and had site-level monitoring of emissions. And during EU ETS, they do recognize the value of CO2 emissions, but the EU emission allowance price tag represents a minor factor among many other investment factors that decides for investment decisions. So increasing electricity prices is perceived as the strongest influence. It has led to the strategic decisions about searching for alternatives to the electricity spot market and also reinforced commitments to energy efficiency. So the conclusion is that EU ETS had a limited effect on long-term and innovative low-carbon solution in these companies. So together with co-author, I also did research on the third period of EU ETS, and more specifically about the benchmark-based free allocation rules. So the work published in Climate Policy involves an assessment of allocation and its implications for pulp and paper sector and cement sector in UK, France and Sweden. It involves quantitative analysis of the member states' plans for allocation in the EU ETS third period. The results are that on an aggregated EU level, for both the pulp and paper sector and the cement sector, there is a reduced free allocation by 15 to 70% in 2013 compared with earlier period. In cement sector, there is in all three countries there is a reduction of free allocation compared to the second period until 2012. And this is more or less expected, since cement sector is a very homogeneous industry. Nevertheless, we can expect long positions in many cement companies, meaning the supply of allocation is larger than the verified emissions. The interesting results are in the pulp and paper industry. First of all, we can see that the pulp and paper industry has reduced CO2 emission since the start of ETS in Sweden and France by as much as 50%. And there was also contributions here from abatement. Not only that certain plants or mills are closing down here, also abatement. And the outcomes of new allocation rules are highly dispersed for this heterogeneous pulp and paper industry. The EU-wide benchmark did not provide a stringent representation of the industry's fossil CO2 emissions. Especially in Sweden, the free allocation is conspicuously high. It is almost 5 times higher the emission level in the third period. So the Swedish condition for low carbon production of pulp and paper involving access to raw material, renewable energy, and production in large integrated mills are very much rewarded in the third period. One aspect here is that the reference fuel for the EU-wide benchmarks is natural gas, while the Swedish pulp and paper industry has a fuel mix of 90% biofuels. So, and also the heat and fuel benchmarks will further complicate the outcomes of allocation. What we can see here is that also biogenic CO2 emissions from biofuels have become entitled free allocation in the third period. This is what I'm talking about in the Swedish example of pulp and paper industry. We can see that emissions have decreased over this period since 2005. Allocation in first period, allocation in second period, and allocation in third period, which is grossly increased due to the reason I tried to explain here. And I encourage you, if you're interested in these particular issues, to read the paper or article. I can draw three main conclusions from this dissertation and research. One is that the failures of EU ETS to enforce a stringent cap and high enough and stable CO2 prices calls for complementary industrial energy efficiency policies. There are so many merits with energy efficiency, and this EU ETS bubble should not be taken as an argument against complementary policies. The role of evaluation should be strengthened to inform and improve policy processes. And what I learned was that the theory-based evaluation approach was very, very valuable. Especially when programs such as PFE involves many incentives and obligations. This theory-based approach helps the evaluator to become familiar with the program and its components, its goals and intended results. So in a dialogue, the evaluator and the administration agency can become better informed about implicit assumption about program operation and make program theory explicit and identify the need for relevant monitoring. So this is something that you can learn as an evaluator. And the third conclusion here is that the program approach that centers on energy management system with many linkages to other incentives and obligations. This is a good starting point for program design. And you can read more about this energy management system program approach in this source it is this report involves not only results from the Swedish PFE example, but also from Danish and similar program in Ireland. With this, I would like to thank you for the attention. If you want to contact me, you have my details here. And I'm ready to answer any questions.